Hope you can see my screen.
We can.
Thank you. Okay. So this is about regression analysis, and there are many things about regression. What is regression? Regression is nothing but a causal relationship between dependent and independent variable. What is causal relationship? So let me start with very simple on whiteboard, then we will go from there. Okay, you can see whiteboard.
Yes.
Okay, thank you. So one is dependent variable first, and another is independent variable. So what is causal relationship? Pi is, let's say, dependent variable, which is a function of x, which is, let's say, independent variable. For an example, sales of any business is function of advertising or marketing or promotion. So marketing is independent, sales is dependent. And this is represented very simply. Y equal to M A plus BX. So Y is dependent, X is independent, A is intercept, B is a slope. How to represent? If you plot these two variables together, this is, let's say, X, this is Y, and let's say the line is coming like this. This difference, or this is called intercept, which is A. So distance on this is A. And how to get B? B is, you make a 2-point on line anywhere and put perpendicular and horizontal lines. So okay, just so this is difference in Y, which is whatever value is here and here, and difference in X. So whatever X2 value and X1 value, similarly Y2 and Y1. So B, A equal to this intercept, B equal to, it is denoted by slope, or it is also known as slope or gradient. Or in other words, here you can say by2 minus by1 divided by x2 minus x1. So this is the way we can get these two things. So once you know the A value and B value, then given X value, you can predict the Y value. So this is a cause, and so this is a cause, and this is the relationship. This is called causal relationship. Simple relationship is explained by correlation. Correlation. So before going into the regression, there is a correlation. And the correlation is a simple relationship between two variables, and regression simple is causal relationship between two variables, or between dependent and independent variable. So this is like, you want to predict your salary based on your performance. So performance should be on 1 to 10 point scale, and you can predict the salary. Similarly, many aspects are there that can be predicted. So I'm just going to open some data, and then we can just look into that. So file open. I'm just going to show the Minitab. Just a minute. Mm. Just a minute. Let me pull out the. Mm. Or let me make a simple. Let me create the data myself. Where is okay. Share screen. Okay. So let's say, the biggest or most important thing this is going on in US market is housing prices. So housing prices. So I'm just creating a data. And let's say this is square feet. So in particular area. So we can predict the value of our house. Let's say I'm just going to insert 50 house price. So I'm just going to put here 50 house price, random data for integer. And let's say I'm going to put from 2000, let's say 50, only 50, and generate in housing prices, and minimum value I'm 350,000, maximum value 525,000. Okay, 25,000, one more. So this is housing price, and just corresponding I'm generating square feet. So here I'm just going to do again random data integer, and here I'm square feet and 50 and 200 square 2000 square feet to, or 1500 square feet to, let's say 2200 square feet or 2400 square feet. So this is the, let's say this is, oh, did I do something wrong? I think I did something wrong. This is the housing, and let me do the pricing again. Something is so, or here I'm just creating a new one. Calculate random data and integer, and oh, I did both of them, you can see. Therefore, it has been changed. And from 15, what was 350,000 to 525,000. Okay. One more zero, and that's it. Yeah, now I have my data. So I believe, I assume this is the real house price and this is the real size of the house. And I would like to, based on the housing price and data, square feet of size of, I would like to see what would be the price of my house if my house is 1800 square feet. How I can know? So here, this is I'm just going to see, first thing, to check the correlationship. And here, number one thing, square feet and this. How I can see, and here by, store correlation matrix. Pearson, there are two methods, Pearson and Spearman. By default, we take, and here we say, and now look into this. So basically, you can see this is the relationship that has come, which is, you can say this is the relationship. you see the p-value is this, means this relationship is not here. You can say correlation is minus 0.032. That means what we can say, there is no relationship. How we can do? There is a hypothesis which I will show you. Correlation is close to 0. Correlation range starts from -1 to +1. And p-value is 82, which is null hypothesis says, let me put, so correlation, the null hypothesis say, okay, rho equal to 0, H0. This is for correlation. And H1, please remember, rho not equal to 0. So this is for correlation. Correlation, small r is denoted for correlation in sample, and this is rho for entire population. So rho equal to 0. When this null hypothesis, when alpha A is equal to or alpha is greater than p-value, p-value is greater than alpha value, then we will accept the null hypothesis. If p-value is less than alpha, then we will accept this alternative hypothesis. So for correlation between housing price and square feet, what we can say? P-value is 82%, alpha is only 5%. What we can say? Rho equal to, there is no relationship between housing prices in square feet based on the data. If there's no relationship, there's no point of doing correlation. However, we are just doing for the sake of crunching the number. So this is the first hypothesis. You have to check the relationship in terms of correlation. Now I go under this. Here I go under statistics. Here we have a regression. We have to choose the regression model, fit regression model. And you need to figure it out, which is dependent variable. So housing price is dependent variable. Independent variable is square feet. We have different options here, models, we have residual, we have Darwin-Watson test that, you will see in next class. So this week, just we have different options here. Results can be stored in different Darwin-Watson test. Darwin-Watson is used when you have, time series data to do the regression. So I'm not going to do anything, just selecting the house price and square feet. Here you can do categorical predictor, means 1, 0, 1, 2, 3, 4, based on different rating. So I'm just going to do, and let's look into this. Our purpose is to just check the this. So here you can see house price equal to 287,180 minus 17.9 square feet. What is the meaning of this? This means even if you have 0 square feet of house, it will cost 287,000. Because you put 0 here and this will be a 0 and this will remain. So now look into this. Here constant, again, all constant are 0, null hypothesis, all constants are 0, all coefficients are 0, and alternative not 0. So null hypothesis and alternative, I can show you this is the R indicate. So this is just, we see, correlation equal to 0, not equal to 0. Now we see the regression one. The null hypothesis, and see beta 0 intercept, beta 1 is slope, and here null and alternatively. So null hypothesis says all all intercept and constants are 0. And alternative says not 0. So here, two unknown parameter are, let me see where, which slide has that. So just to understand, V0 and these are 0 and alternative is not 0. So look into this. Again, look into the coefficient p-value. What is the p-value? P-value is 0.084, which is more than 5%. And this is 82%. This means both null hypotheses are correct. That means both are 0. Means both are useless in the model. So how I can write? Null hypothesis H0 equal to, or colon, slope and intercept, or you can write the symbol all 0 equal to 0. Alternative says slope comma intercept not 0. Now look into this. Again, the same p-value is more than this. That means this is correct. For this is correct, means they are 0. Means whatever value you will put, suppose this is the model, you are going to buy a 10,000 feet house. What would be the price? It will not be significantly different from this, and we are going to check. So this is number one thing to check. This is a model or this is an equation. Now look into the coefficient. This is a coefficient, both of them. This is a model summary. Look, S is standard error in the model. This is R square. R square means R square can be 0 to 1. 0 means no causal relationship. 1 means 100%. Means only this is 0.11%. How much? 0.11%, less than 1% relationship or causal relationship established between square feet and housing prices. Adjusted R square is 0. Adjusted means unwanted, residuals are removed from the model before doing the modeling. So this is R square is always, R square adjusted is always smaller than R square. So which is 0. That means this model is useless to predict. And now I can show you the same thing. Let's see, this is the stat regression I'm going to do here. And here we have the predict option. And this option starts when you finish the model. If you do it very first stage, no. First you run the model, then it will understand the predict. So just do it. Now I'm going to take 3 houses. One is 0 square feet. That means just land. Another is 1,000 square feet. Third is, let's say, 2,000 square feet. And last is 10,000 square feet. And see what is the difference you get. So here we have the 3 house. Predict, this is 0 square feet. For 0 square feet, fit value is coming to 187,000 because this part is going to be a standard error of it. Range 95% is minus to this, which is very, this is unusual. So for 1,000 square feet, how much it is coming? If you have more, bigger size of house, the price of the house is reducing. If you have 2,000, the price is, and 10,000 square feet house, you are just going to pay how much? $100,000 about. That means this model is not good, means our data is not good. So this is the way to predict. Now I'm going to show you some, real data. Let me see if I can get Indian. Here I got the. Okay, I got the real data that I explained the case of Indian students admission in USA. And let's see, where is the date? Okay, right here we have the data. So do you remember this case? I think I spoke in previous class somewhere. This is the chance of admission. Chance of admission in any university depends on GPA, a statement of purpose, letter of recommendation, university rating, all these things. So let me do, this is basically not simple regression. This is multiple regression. So I'm just going to run a model. Before running, let me do the correlation. So here we have correlation, and let me run the correlation. Let me do all in one time. Okay, and let me do this. And let's see. So we will get the pair and matrix. Now you are going, so this is a pair, TOEFL and GRE, university rating and GRE, and you can see this is the all permutation combination of two variables, pairwise correlation, and this is the correlation matrix. So look into this. Based on P value, do you see any pair is having useful or useless relationship? Null hypothesis, you can say, in wording, I can say rho equal to 0 and rho not equal to 0. So this is null for correlation, and for alternate this is, and this you can say useless, and you can say useful in wording. Now you please tell me, do you see any useful relationship, correlation, any pair, or any useless? Do you see any useless relationship?
It's all useful.
All useful. That means, this is all relationship exist. Means there is significant relationship, and you can see their degree, it's 82.82. So minus 0 to minus 1 to plus 1. This is the range. So you can see these are all in positive side, all the relationship are positive, that you can see. Now, okay, I see now it's useful to run the regression model. So now I go and run the regression model. Statistics, regression, and I just go. And now we know very much the chance of admission depends on different thing. Now we have to see the continuous predictor and categorical predictor. Categorical, so you can see in data research university, not research university. These are the two options. Here you can see the university rating. These are also categorical, 1-star university, 2-star, 3-star, 4. But regardless of that, I'm just going to use all of them together here in continuous. You can select separately, so you will get two different model. Now I'm just running here. And now you can see this is the model, and here minus 1 point, this, then GRE, then score, then. Now tell me which variable is useful and which is useless. Hopefully you can see my screen. No.
Is the GPA useful?
GPA, where is GPA? Yeah, GPA is useful, certainly. Tell me which are useless.
The SOP?
A statement of purpose, certainly, because we are checking at 5% and it is coming 72. So null hypothesis, that means it's useless. What is other thing?
The university rating?
Exactly. This is the another one. This is useless. So, you know, means, you know, university rating and statement of purpose does not affect your admission. Means if, let's say you don't submit these two, you don't submit the statement of purpose in your application, that means your application is not going to affect any in terms of admission. Means because it's useless, if you get a 0 out of 5, it will not make any impact in your application, and we are going to see that. Look into this. R square is 82%, means 82% chance of admission depends on these following variables. These following variables are explaining 82% chance of admission. Adjusted R square, as I said, R square is little bit higher, is adjusted is little bit lower. Why? Because, you know, these useless items are removed from that. So this is little bit lower, always lower. Now look into the analysis of variance. This we will learn later. These are the unusual observation. Here you can see out of 500, few observations, you know, are unusual that model understands. Means these are not as per trend, as per that. So if you remove these items, number 10, number 11, 40 or 64, whatever number are given, you will have better forecast. Or you just go and check your data. What is the issue? You know, probably you did mistake in order to get the response or in order to collect the data. So basically this tells you, you just see and just check your data again on these observations, because these are unusual. So let's say the 10 number, so this is a 10 number. GRE score at 323, TOEFL this. Here chance of admission is only 45%. So probably you need to check again. What is the reason? Now let's look into the two. So this is a model. Let's see. I'm going to see the prediction, regression, and predict. Now I'm going to do two things here. I'm going to do same numbers. I'm going to put SOP 0 at one place and one place maximum. I'm going to put one place university rating 1 and one place is 5, and see what is the difference that you can see. GRE is, let's say, what is the range? GRE 323. Here I'm also putting 323. TOEFL is 108. 108. University rating, here I'm putting 5. Here I'm putting 1, which is lowest. A statement of purpose, here I'm putting 5. Here I'm putting, you know, 1, which is lowest. Letter of recommendation, I'm putting 4 here and 4 here. GPA is university rating, GRE. And GPA, I'm just putting 9 and 9. Research university. So I'm just putting research, both research. Okay, now look into this. So when, you know, you see this first, where I put these numbers, the chance of admission is coming 81, or you can say 82%. Okay, 82%. When I made both the items highest and lowest, which are in sigma, it is coming 79%. So basically, if you choose any university, high or a statement, these are not going to impact your chance of admission much. So that we can see. So this is, you can predict. Now this is a confidence interval of prediction. This is a predicted interval. 95% predicted interval. So this is about regression, that simple regression. And we will learn more in next course, which is going to start from Monday in detail, multiple regression with all the principles, all the concept. And I decided I'm not going to keep this topic in our in this exam. So you don't have module number 6 in final exam. Up to five module you will have in exam. So any question related to this, please let me know.
Should we just ask now or message you later for questions on this?
On this, you can message, you can ask if you don't understand anything, you can mail me. I'm always there to help you. So any question if you have related to that, you can ask now, you can send me an email. I will answer as soon as possible.
Okay, well, just curious, which of the values as you were running the regression, which of the variables would actually be the standard error of regression?
Okay, so this is a very good question. So let me go into this is the chart. So this is the model and this is the R square. So this is and here you can say one more thing I wanted to explain. This is the standard error of regression because this is a model. This is R square.
Okay, helpful. Thank you. And so would that be representative of, and this is a bit leading because there was a question on the homework, so feel free to answer it in a different way.
Yeah.
That there's, how would we determine how, no, sorry, brain fart. How with that standard error, like and I'm just gonna cue it up for how it is in the homework, that the actual body fat deviates from the predicted values.
Yeah.
So like, how do we find that standard error of the
in terms of percentage, how you find? So 5%, 6%.
Yeah, I think it's more how do we find it?
So basically, this is the this is the deviating from the. So it's a 5% or close to 6% in this.
Oh, okay.
It's a you can see this is 5 and close to 6%. Now I remember one more concept to explain. So here you can see, do you establish any relationship here? See this into this into this. There is a relationship in coefficient, standard error of coefficient and t-value. And you can see, and let me do for you. So here you see 3.7 divided. Okay, just multiplied with 0.000502. So this multiplied with this, you get this number. T-value standard error of coefficient, then you get coefficient. So there is a coefficient, like for example, what is 0.0018? Where's 0.0018? Yeah, this GRE score 0.001859. How we get? T-value multiplied by standard error of coefficient, you get the coefficient. Let's do another one. So here 0.35, I'm just doing for this SOP, 0.35 multiplied with is 0.00456. And now you get 0.159. So you get if some some of the fill in the blanks I give, I give this table, I ask what is the t-value, I give 2 of them, you get third automatically by subtracting or dividing. Oh, sorry, by multiplying or dividing. What is this variance in inflation factor? This is related to multicollinearity. Multicollinearity means high relationship between variables. So if VI, Darwin-Watson test says if VIF or, the multicollinearity, if it is up to 1, no multicollinearity, it is up to 2, no problem. Even some researcher, they say up to 5, no problem. But, more than 5 is issue. So variance inflation factor is another thing, another important aspect that we will learn in next course. Why? Because, if you have like let's say, these two variables are same, or all the variables have a high relationship, 90% or 99% or 0.99, then they are showing exactly the same behavior. So multicollinearity explains if two variables are having exactly same behavior, and there is no point of having two variables there, because one will represent exactly the same. So this is related to multicollinearity. Since we are not doing multiple regression, therefore, only one variable, therefore I'm not talking now. But when you have multiple variables, we need to consider this also. Yeah. Any other question? If you don't have, then I would like to say a wonderful night. But before that, please submit everything. Please complete all the tasks by Sunday, because Sunday midnight or Monday morning, we will have next class started. We'll have next class, 5:20. So please, finish everything by Sunday night. Okay. As you
Okay,
I
can,
have
thank
one
you.
question if that's, sorry.
yeah, please go ahead.
Just if that was the end of the class, there was another question that I was really curious about the wording on in the homework, and just kind of where to find it in the variables that are represented in Minitab. And that is, it said, indicate the value of the test statistic that
Yeah.
indicates this regression is useful.
Yeah.
And I mean, I feel like there are so many different answers for that. So I wasn't.
So regression, this is the test statistics.
Okay. The F value for the
Yeah.
fit.
Yeah.
Why would the F value be used rather than R square? Is
Okay. So basically, since this is a multiple, so R square is, the causal relationship between dependent and independent. So this explains degree of relationship between, the impact of these, 6-7 variables are causing on admission. So this explains that degree. It doesn't have statistics. Statistics are either F value, T value, Z value, that is statistics. So for regression, this is the F value. For GRE score, this is the F value. Because, we are doing ANOVA in this, analysis of variance is used when you have more variable. We will talk when we will do multiple, when we deal more than two variables and things, then we use multiple ANOVA, and F value is used. So this is F distribution is useful.
Thank you.
You're welcome. So Mandy, you are asking, can you let us know what to expect in the final? Yeah, I mean, what is this? So final, actually, if those who have studied and those who have worked seriously in all 5-6 weeks, the exam can be completed in 30 minutes. The exam can be completed in 30 minutes only. Some people or some students have done in past 15 minutes also. So and you have all the resources available with you. I'm not doing any proctor exam. That means I'm not looking on your side. You have book with you, you have notes with you, you have Minitab with you, you have Excel with you, you have everything. So it's all, it's like, but only one thing, you have 2 hours time to do it. That's only one constraint, and you don't have multiple attempts. Because already 80% grades have given for the learning, doing multiple attempts, and so, but this 20% to check the or evaluate the learning that you have accomplished during last 5-6 weeks. So this is about final exam. It's most of the questions will be very conceptual and very basic questions. Any other question, Mandy? Am I able to answer your question? Most welcome. So please do all the, everything by Sunday night, and we will meet for next class on Monday. Okay.
Thank you.
Most welcome. Bye bye.
Bye-bye.
Good night.
Thank you.
Bye-bye.
Bye.